Well, in the previous video where I presented the calibrating model, uh, I actually mentioned something that I think it deserves a word of caution. And it has to do when we use variables that are derived from the dependent variable. So in this model, we are actually using two of those variables. One is the inflow from the previous day, and the other is the average of the inflow in the previous 3 days. And it could be tricky because adding those variables is an easy way to suddenly improve the apparent performance of the system when it's not really true. So in this image here, I'm showing the result of 3 variations of the model. In the first one, that corresponds to this one, we actually are not using any of those derived variables from the dependent variable. And as we can see, the results are fairly good. Right? Here in the table with the results, we can see, for instance, that the Nash-Sutcliffe for the mean is 0.624, and this is actually what we're looking at here. If I then add these other derived variables, well, we can see that that value improves to 0.741, and actually it's this one here. So it's fairly, better than the previous one. But what if I only use those derived variables? So I create a fullness model that will try to predict the inflow by just using the inflow in the previous days and the average on the previous 3 days. Well, still we can get a very good model. Right? It looks like this one here in the top and right. We have 0.48. So we could say, well, this would be a pretty good model to predict the inflow. Well, not really. We're seeing here, what we're saying here is that, you know what, the flow tomorrow will be pretty much similar to the flow today, which is true, but it doesn't really give us any warning, any forecast. So this happened to me a few years ago. I was building a model that was in a regression. It was a regression model, and then I got to results similar to this one. This is actually fullness, but the idea is similar. And I started looking and say, oh, looks really good. And so I'm catching all the peaks and everything. But for some reason, it was too good to be true. And then after further study, I realized that this is what was happening. So if I zoom in, I see that, yes, I have all the peaks, but I have them the following day. And then looking at my model, I realized that the weight that previous day flow had in the model was extremely big compared to the other ones. So actually what the model was saying is, well, okay, tomorrow will be pretty much like today. I call that for myself the Hermann gate, because I was getting in deep trouble if I wouldn't cut that error, because I was publishing as a very good model when actually it was not. So this is as I said, a word of caution. Just make sure that your model works fine with all the independent variables completely independent. And then, if you want, you can try add some of the dependent or derived dependent variables and make that analysis before including them in the final version of your model.